Hello, this is Marley Evans, and I am doing a little bit of a presentation over the general circulation of the atmosphere. So, kind of like the first thing that I wanted to touch on as I dove into this topic is like, what is that driving force that's going to be making all the circulation take place? And the answer to that is wind. Okay, so like what we're looking at is we're looking at these giant air masses, like giant immense bodies of air moving across our globe, which is like basically a description of wind. So, wind is any horizontal movement of an air mass, like at any point in time, basically. So, as these bodies of air are moving, that movement is called wind. Um, and so, like one of the like right off the bat, most easy things to kind of understand about wind and the way that they move is the fact that they're most of the time it's this air mass is going from areas of high air pressure, like a high pressured area, down to a low pressured area. So a good way to remember that is going from high to low pressure is if you think of a balloon, right? Whenever you fill up a balloon with all that air, the pressure there is very high because all those air particles are wanting to escape, but they're being contained by like the balloon aspect of the structure, right? So as like they're bouncing off the walls, the pressure within that balloon is actually building, right? So if at any point there's a hole poked in it or you release it, the pressure that has been building within that balloon is going to be very high. So all of those air particles are going to be going out of whatever hole, whatever uh, fissure there is down to like that lower pressure area, right? So it's going to be going as quickly as it can from high to low pressure. And as we see that, like on the globe, right, on our continent on Earth, um, like that's the movement of what the air is. It's like anytime you have high a high pressure area, the wind is going to be dispersing from that in all directions down to those lower pressure areas, which this is super cool. This is like the very foundational aspect of learning how wind works, right? But we're actually going to build on that, and there's some more aspects of how wind works and how like this general circulation is taking place that we get to look at. Um, so right here, this is like a visual representing the Coriolis effect, which is like another additional thing on top of the high low pressure that impacts wind, like the wind's movement. So the Coriolis effect is basically just recognizing the process that Earth's rotation has on these air masses, right? Because as the Earth is slowly rotating, those air masses are therefore going to be impacted. An example from our textbook of how to easily understand this is like if, for example, an airplane or rocket, if you will, was placed at the North Pole. If it was shooting down, it was trying to travel over like the longitude of Earth down to the South Pole. As it's leaving the North Pole, as it begins to take its journey down towards the South Pole, the area that it is flying over, that longitude is going to slowly be adjusting as the Earth is rotating. So, say originally that the rocket is at that 0 degrees longitude line as the Earth is rotating, right? Because it's slowly going to be rotating. The longitude is going to be changing, and that's going to be impacting like basically the flight trajectory of that plane. So similarly, wind is also impacted by that. Like we don't really feel it since we're standing on Earth, but like wind or air, really, these air masses that are elevated above the Earth, they feel that impact. They feel that like that rotation, which is going to be producing this like different movements of air within our Earth, which is really a cool thing to like a really cool thing to consider because like as it's spinning, they are like building off each other. It's like right here, all of like this region right now, this is going to be all high region. Okay, so these are like our high pressure areas, high pressure regions. So right here, we see that this area is like high pressure. So the wind, the air masses are moving away, creating right, heading towards the equator, downdrafts of air, heading up towards the North Pole, creating updrafts of air. But as these air masses are moving down, we kind of see the fact that they're not going down at like a straight 90-degree angle towards the equator. They're going down at a slope, and that's because of the Earth's rotation. Like that's this whole Coriolis effect at play, which is really cool to look at. Um, and like something else to consider when it comes to air, like in addition to this Coriolis effect and moving from high to low air pressure areas, is that sometimes like this this different movement of elevations that these air masses are going through, sometimes that's going to be resulting in clouds being formed. So in my other video, we talked a little bit about this, about friends in airlifting and how as bodies of air rise, all of those warmer air particles within that cloud are going to be condensing. As they condense, as they cool, and as they condense, they're going to be forming clouds. Um, and these clouds therefore lead to different types of weather, right? Like sometimes this is going to be just rain, sometimes this is going to be a storm, such as like a thunderstorm, sometimes it's going to be something more severe, something that we're going to have to like dive into another time. Um, but the really cool thing is that kind of this whole process, right? The low to high, oh, nope, that was wrong. Like the high to low and the Coriolis effect and the fact that, hey, sometimes weather happens. This is like all touching on that general circulation of the atmosphere. And something that's really cool is within that, like these different wind patterns have various effects on weather, which is really interesting, like on climate. So like those areas that are bringing in air masses from high pressure down to low pressure that may have formed over a like body of water called like a maritime air mass, like a maritime air mass, are those ones formed over water. As those air masses are moving to a different area, all that moisture is going to be dropped out of it, and all of that moisture is going to be released, creating a region of like the globe that most likely is very prone to having lots of rainfall, which is really cool to think about. But then also, like on the other side of that, there are also times that air masses are formed from the like over continental areas, right? Like over land areas, and those might be a little bit drier. And so, as those continental air masses are moving, you're not going to see as much precipitation, which actually sometimes might lead to even desert-like areas, which is crazy. That wind and air mass of all things is what impacts things like having like a significant amount of rain or having a desert, which is the opposite of a significant amount of rain. Finally, I just want to give like an example of how the different air masses can not only impact climate, which is like that long-term weather, or like long-term measured and predicted weather, such as like those like rainy, cold, those rainy climates and those more dry climates. In addition to all of that, these fronts and these different wind patterns can also have a hand in how like the day-to-day weather is happening, even things that are more severe like tornadoes. So as like the wind is circulating through, like this general circulation is happening, those like different air masses I was just talking about are also coming into play. So Oklahoma has a good amount of tornadoes because we are in an area called Tornado Alley. Obviously, I'm sure we've all heard it living here, but within that whole concept is the fact that like the Oklahoma state, like the Oklahoman state, is placed on this Great Plain area, which is going to not offer a ton of friction, not offer a ton of hindrances for different air masses to meet. And as those different air masses meet, right, coming from the projection that their wind is blowing them in, based off of the Coriolis effect and just the fact that air moves from high to low pressures. All of this is going to play a key role in bringing those different fronts together and having like those prime conditions for a tornado. So it is very like intermingled, but super super cool to get to look at. So thank you guys so much for your time. Thank you so much for listening. I hope this maybe answered a couple of questions for you. Maybe got to clear up a couple of confusing topics, but I hope you guys have a great day. Thank you again so much for listening.